Hello, I'm Stefan Greber, I'm project leader for LXD, and this is another live stream for a Elixir release. In this case, it's LXD 5.15, which was tagged on Wednesday and started, got proper announcement and everything on Thursday. Doing this a bit earlier than usual this time around because I'm off next week. So couldn't do the release live stream on Monday, so I ended up just kind of shifting everything. That being said, we're obviously not starting an actual rollout to stable users just before a weekend. So the actual rollout will begin on Monday as usual. So it's just kind of the rest of the things that have been moved a bit in time here. Now, as usual, let's just go through kind of the release announcement itself and go through a bit of demos after that. There are 4 new features in this release with the couple pretty big highlights and then two slightly smaller ones. So the big first feature we added is support for non-UEFI virtual machines. You may know that LXD has always used a very, very modern machine definition. So we're using QEMU's Q35 machine type combined with a UEFI firmware and including UEFI secure boot on the VMs. And then we support a number of other things on top of that, like TPMs and the like. It also means that LXD effectively uses PCIe hot plug on every single device, which is very convenient for adding disks and network and that kind of stuff at runtime, but gets a bit in the way for older operating systems. Now, we expect pretty much all of our users normally use our own images or they install something like Windows, and all of those support UEFI and there's no issue whatsoever there. But a pretty common issue lately has been people migrating out of existing platforms. And because a lot of other platforms have not used UEFI and instead tend to use old-fashioned BIOS, well, that's where some problems are happening. So that's specifically affecting people moving out of OpenStack or moving out of VMware. Those platforms tend to have a much older machine definition, which does not support EFI. Now, there were kind of 2 ways to support that. One way is that LXD could have done the same route as those platforms and offered a very old machine type and then started supporting that using effectively a legacy BIOS firmware on there and no EFI. That's an option, but that gets quite annoying. LXD likes to very tightly integrate everything. And so having a completely different PCI layout, having to deal with completely different virtual devices, having to deal with completely different firmware and all that stuff, that would have been a bit of a nightmare for us. It would also have become a bit of a problem for anyone trying to do things like confidential computing, where being able to measure all of the firmwares and all that stuff is quite important. And so having big variations in the way things work from one VM to another, that would not have been ideal. So instead, we went a different route. On physical systems, if you, like probably on any of your laptops on your NAT, you'll notice that you're running UEFI, and pretty much every system in the past decade at this point has been running EFI. But often there is an option to run legacy operating systems. It's called CSM, and it's an option that you can turn on in your firmware menu usually, at which point you can go and boot a non-EFI system. So CSM stands for Compatibility Support Module. It's effectively a small module of, as in small piece of independent code that can be run by an EFI firmware, which will then implement roughly what's expected of an old-fashioned BIOS and allow booting through that. EDK2, which is the UEFI firmware that we're using for LXD, does support including a CSM module. So that's what we've done now. We've effectively made a new build of the firmware, which includes a CSM component. That system component is based on CBIOS, which is the standard BIOS used by QEMU. And when that's enabled and when UEFI secure boot is disabled, then you can effectively boot a system that doesn't support UEFI. So that's now in 5.15. It's not as simple as LXD itself supporting it. On the LXD side, there's actually pretty little we do other than picking a different firmware, requiring UEFI secure boot to be disabled, and tweaking the PCI layout of two cards. That would be the graphics cards and the SCSI controller. Just so that the legacy firmware can actually find disks and render screen output. So that's what LXD does. The other piece is you do need to have an EDK2 build which includes CSM. And most Linux distributions don't do that, but the LXD snap will have it built in. So if you're using the LXD snap, it should be fine. If you're using another distro, you might have some difficulties around that, as not all of them have it. And those that do have it might not have a build that supports the kind of devices that LXD itself has. And also the current CBIOS upstream actually has a bug, which means that even if they did make a build and they're using the normal upstream version, it won't work unless they've actually cherry-picked one or two fixes from the upstream repo. So it will work fine with the snap. Experience on other distros might be a bit hit or miss until those distros, until either CBIOS releases a new version with the fixes, or those distros include the missing bits. All right, so that's for the CSM bit of LXD. The next piece is support for rebuilding an instance. So that's something that we've occasionally seen some need for. Effectively, you have an instance that's been configured with extra disks, with extra networks, with potentially proxy devices and all of that kind of stuff. And it doesn't work, or you want to just reset it completely. So currently what you need to do is save the config, delete, launch a new instance, reapply the config. Now we've got a command that does it in one shot. So it's called Elixir rebuild, and it takes an image, it takes an instance name, it will effectively delete all of the storage of that instance, and then put a new image in its place. The instance will keep the same MAC address, it will keep the same everything as far as configuration, but its storage will be completely reset. So that's instance rebuild. It's pretty straightforward syntax-wise. It's the same as like a launch or init, except that it goes against an existing instance and just replaces its content effectively. Then the next issue we've got, the next feature we've got is support for NUMA nodes in the LXD scheduler. So LXD, for container anyways, has support for limiting the number of CPUs exposed to the container. So that's limits.cpu. And when you set limits.cpu equals, say, 4 on a system with 8 CPUs, LXD, the kernel doesn't really support doing that. So LXD, what LXD will do is that it will actually go through all of the CPUs on your system and then balance containers with specific pinning for each of those instances, effectively picking 4 of your physical CPUs and pinning the instance to those 4. And then as more and more instances get started or stopped, the scheduler runs again and changes the exact pinning to better balance things on the system. That's how that works on our side. That scheduler had no idea what a NUMA node is. So if you're dealing with a system with multiple NUMA nodes, which typically are multi-CPU systems, LXD would just balance across the entire set of CPUs, leading to instances that were that potentially had half the CPU on one NUMA node, the other half on the other. If that instance runs a lot of independent processes, that might not be an issue. But if you're running a bunch of processes that need to share memory and exchange data, that can become an issue because you effectively have 2 processes running concurrently on 2 different physical CPUs. And if they need to share data, they can't just do that very easily through the same directly attached memory or even one of the caches. It instead needs to go through a bus to go from one CPU to the other CPU and then to that memory. That can be quite expensive. So now we've got support for specifying what NUMA nodes should the scheduler be looking within when it does pinning. So in the syntax I've got here with limit CPU 4, limit CPU nodes equals 2, that means it will find 4 CPU cores for that container out of whatever is available on NUMA node number 2. And you can also specify multiple NUMA nodes. So if you've got some pretty weird systems, and of course the case with like the first generation AMD EPYCs, where each CPU actually was actually exposing multiple NUMA nodes per CPU, then you could give a range of those NUMA nodes so that LXD, instead of pinning on just one of the CCDs, so like one of the triplets of that particular CPU, would instead pin on any of the triplets within that CPU. So yeah, that's effectively what we added there. That should be pretty useful for environments where speed is very important and when there's a bunch of shared data in memory. And the last feature we added is mostly going to be to help out the folks working on the LXD UI, but it's simple extra fields of metadata in the LXD API to tell us what user the user is logged in as, or more like what user does LXD see for that particular connection, and how the user was authenticated. So in the example here, I'm using a canonical RBAC, so it will show up as candid and then as my username at internal domain. So that will be quite useful. That way, LXD UI can check whether you're authenticated through a TLS certificate, or authenticated through Candid, or authenticated through OpenID, and know whether you can log out or not, and where to go if you want to log out. All right, so that's what's new in LXD 5.15. On top of that, we've fixed a lot of things as usual. We've got a few new team members who just joined the LXD team at Canonical. And usually when it happens, we put them on bug fixing duty. So we've been fixing quite a lot of our bug backlog, and that's what you can kind of see here with all of the changes. There's still a bunch of more bugs for them to look at, but yeah, we've definitely made quite a bit of a dent in this release. Alrighty, now let's switch over to a terminal and gonna go through the first few things. Actually, a terminal might not be exactly ideal for this one, but let's see if I can. So I'm gonna need to share the virtual machine afterwards. Let me see. Oh, well, that's convenient. This thing shares my entire screen, apparently, so that's cool. I can use that one. All right, that will work. Just needs to get rid of a few more windows on that screen, but other than that, that should be okay. All right. So here I've got a project with one instance. If we look at that instance, we'll actually see it's got some debugging left over, so I could actually get rid of that. CSM ra QEMU ra there. Okay, so now it's got a much cleaner config. So we can see it's a VM with 4 CPUs, 4 gigs of RAM. It does have CSM enabled, which requires secure boot to be disabled. And that's pretty much it. What's in that VM is actually an Ubuntu desktop install, which I made going through CSM. So that installation does not use UEFI. Now to show how that actually looks like, if I switch over to here, there we go. I'm gonna start that VM. Oops. Keyboard misbehaving here a bit. Okay. Start CSM and console VGA. Okay. And I'm gonna stop it in the firmware to just show you what's different. So if you do escape and go into the firmware menu, it still looks like perfectly normal EDK2 EFI menu here. But now if you go onto, actually just noticed the webcam is looking wonky, so I'm just gonna hide it, there we go. Okay, so if you go into the boot manager, you'll see here that we've got legacy hard drive and showing hard disk. This is the extra thing that shows up when you do CSM. All of the firmware is still perfectly capable of booting over UEFI, and that's what it shows. All of those are normal UEFI boot options, but it does support booting straight from BIOS instead. So if we do that, we're gonna see a slight difference, which is now we see cBIOS starting. So it's actually starting the other firmware, and then that starts grub, which then in this case boots Ubuntu. And you might notice it's got the Ubuntu logo in the middle and not the LXD logo. That's one of the ways you can tell that it didn't boot in EFI mode. Because if it did, it would have kept the EFI vendor logo, which is the LXD logo. And once you're booted, you can actually go look in the firmware. So sys firmware, And here we can see just ACPI, DMI, memmap, and QEMU firmware config. No sign of EFI whatsoever. And if we try to use the EFI boot manager, it shows that there's no EFI involved. It actually gets kind of funnier than that. If I stop that VM, there we go. Ubuntu is one of those operating systems that actually supports being booted in either mode. So even though this is an install that was not done with EFI enabled, Ubuntu still supports it. So you can actually still trick it. So if I go back in the menu, and instead of selecting the legacy, I go straight to booting in EFI mode, it will still boot, as it did last time I tried. Yep. And this time we see the LXD logo, so we're booting in EFI mode, the exact same install. And if we go here, come on. Okay, so this time around, doing the exact same thing. If I go look at specific firmware, this time we've got EFI in there. So we are definitely in EFI mode. We can see the variables, vendor, and all that stuff. And if we look at the boot menu, we can see it here too. What's actually funny is that if you look at the boot menu, which we can now get because we're not booted in EFI mode, we can see that it does have the boot entry here for the legacy boot. That BBS, I could actually highlight it for some reason, not sure why. Not this one, the one earlier, this one. Yeah, so this entry here is the legacy boot that we went through earlier. So you can actually see it, you can change the boot order if you boot it in EFI mode, but that VM can also boot in just normal legacy BIOS mode. All right, so that's for CSM. I'm gonna shut that one down. Someone was wondering what that noise was. That's the cat jumping off the desk. Is not in shot of the camera. Not that you can see it right now anyways. If I switch back here. Okay, so now the camera is back and to show you that the cat is in the room. That's a cat. It's just looking like he wants to be let out of the room. It's just being cute. All right. And back to my boring face. There we go. All right. So second feature, that's the instance rebuild. All right. So for that, I'm just gonna do kind of the easiest example, which is we'll just create a basic Ubuntu container here. Okay, you go in there, and this is Ubuntu 22.04. Now we can do a rebuild. Let's do Alpine Edge on top of the same thing. Images, Alpine Edge, that should exist. Not sure why it wouldn't. This is odd. Is there an issue with Alpine Edge? Or did I do a stupid typo? Okay. Let's try that again. Oh, there we go. Okay, so that seems to be working now. So if we rebuild it, it's telling me that the instance is stopped, is running, so it needs to be stopped. There's a false flag to fix that. So if we do now a rebuild of U1 using Alpine Edge, that exact instance that was running Ubuntu before, oh, it's not running anymore. Start it back. Okay. And now it doesn't have bash, which makes sense because this is now an Alpine container. So that's really what you get for with rebuild. It's pretty simple. It just replaces the content of the instance by effectively deleting its disk and recreating it, but the rest of the instance remains completely unchanged. It did reset the image keys because, well, that makes sense. It would be kind of weird if it didn't. But the rest, its MAC address and all of that kind of stuff, did not change. All right, so let's just get rid of that. Now the next one is the NUMA node pinning. So this is a bit of a harder one because I don't have multiple NUMA nodes on, oops, wrong host. I don't have multiple NUMA nodes on my desktop, and most people don't have multiple NUMA nodes on their desktop because that's a bit of a weird thing to have. But if I go here, this is a machine that luckily will have multiple NUMA nodes. So this particular system is actually part of my home cluster. We can see that it has 2 sockets, 2 NUMA nodes, which is what we want, and a total of 48 CPUs, as in CPU cores in this case. All right, so I'm trying to remember what is it in bus system or device system? I don't remember the structure of this stuff. Yeah, there we go. Okay, so we can see the machine has 2 NUMA nodes, node 0, node 1. You can actually get those details in Elixir info -- resources. If we look here at CPUs, it will show us the socket and matching NUMA nodes for every single one of the CPUs. Okay, so now if I was to launch a basic 2204 U1, and I'm just gonna make sure it's spawned on the right machine, and say we'll do 4 CPUs. Okay. So I'm gonna do the launch, and I'm gonna go in that instance and see where it landed as far as the CPU IDs, and then we can correlate that with the list of CPU, well, of CPU to NUMA node mapping from Elixir info resources. And I mean, it's not impossible, but there's a decent chance that this will actually have been spread across 2 CPUs. Like, it's not impossible that they somehow all landed on one, but I'm hoping not. That would make it easier to demo the feature. So if we look at proc self status, we can see we got 2, 9, 43, and 45. If we go here, so core 2, no, actually that's not ID2. So ID2 is node 0. We want ID9, so ID9. ID9 is still node 0. And then we've got 43 and 45. Let's see, 43. 43 is node 1, 45 is node 1. So currently that container is split right in the middle between the 2 CPUs. Now let's go and change that. So if we do U1, limits CPU nodes, and let's do 0. And now go, let's see what that changed. 1, 24, 30, and 33. Okay, so if we go look back here, ID1 is node 0, ID, what did we have? 24, 30, 33. ID 24 is node 0, ID 33 is node 0, and the last one was 30, which is also going to be node 0. Oops. There we go. If we were to instead move that to 1, then going back in, we should see it having moved to 12, 20, 23, 45. I mean, we can just check one of them just for kicks, but you know, kind of get the idea. So ID 12 is on node 1. There we go. And if we wanted to allow both, you could do 0,1 or 0-1. That would actually end up being the same thing in either case. And now we've got 5, 27, 28, and 42. Which may or may not be across the 2, I don't know. ID 5 is node 0. Okay, ID 28, was it? 27, 28, and 42. Okay, 28 is node 0. 27, that's 27 is node 0, and 42 is node 1. Okay, so now it's indeed back to being scheduled kind of across. So that's really it for that feature. I just let you really control the pinning and lock to one or multiple NUMA nodes for scheduling a specific instance. Okay, and the last one is just around authentication. So if I look at one of my clusters, you know, let's do like a my data center cluster. So it's those 3 machines. Now, if I go and just do info on that cluster, it gives me a whole bunch of details. And amongst the details that it's gonna give me is the auth details, and we can see them here. So it shows who I'm logged in as and what method has been used. Now, if you look at that on just your local system, on the local system, it's going to show up as method Unix, and then your user ID. So most people will see UID equals 1000. It's going to be the username effectively. And you can get a different result if you're using OpenID Connect or if you're using TLS, etc. The different methods are all gonna get you the right protocol and username for each of them. All right, so that's it for this release. And that's all we've got in LXD 5.15. As I mentioned, this is gonna get rolled out next week, most likely starting on Monday. And we'll do the usual phased rollout. It's gonna take a little while before it hits everyone. There are a couple of small kind of rough edges and stuff around some of those features that we will be cherry picking fixes for into that release. But otherwise, that's it. So if you've got any questions around this release, you can go and leave them directly on the release post on the forum. And otherwise, I'll see you in the next one. And one last look at the cat before I go. So for anyone who wants to see him, is still apparently just chilling / sleeping in the corner over there. All right. Have a good weekend, everyone, and see you around. Bye.